Good morning, everyone, and welcome to today's webinar hosted by YouSolar titled The Electrification of Everything and the Transition to Decentralized Power. I'd now like to introduce our host and CEO of YouSolar, Arnold Leitner.
Good morning, everybody from California. I'm Arnold Leitner, and I'm the CEO of YouSolar. Welcome to this webinar on the electrification of everything and the transition to decentralized power. I think I should get started with a picture at a classical electric system, which I chose to call the Edison electrical grid. So you have your power plant, then you have a step-up transformer that brings the various power plants to the electric high voltage potential of the transmission towers. Those are those steel scaffoldings out in the country. They run to the load centers, cities, villages, and there is typically a transmission substation somewhere on the way where it splits off and serves sub-transmission lines. You probably recognize those are these kind of rectangular poles, often by the side of the road, and then runs from there to the load centers. And then once you enter the neighborhood, or a commercial park, it steps down to the distribution substation that then serves these poles that you're familiar with in your neighborhood, typically underground in commercial areas, and then from there it goes to your home or the small business. So that's the electricity grid that you envision. And in order to kind of set up our discussion here, let's learn a few terms, a few figures here. So we got our power plant and a step-up transformer that brings things up to 200 and 500 kilovolt, not kilowatt, kilovolt lines, kV lines. You probably know that term. Then it continues on. As you get closer to the load, the electric potential steps down. Now you're looking at 69 to 138 kilovolt and the sub-transmission until you get to the distribution substation where things step down further to about 7 to 13 kilovolt. And then, of course, your home is served with 120 to 40 volt, which we call split phase. Most of you are not familiar with the fact that most of your energy in the house is served at 240. That's the big items, dishwasher and a washing machine and the like. So you're mostly familiar with the 120. For the commercial users, as we'll see momentarily, that are also on these distribution lines, they're receiving often three-phase power. What that is and the difference between them is not really relevant to understanding today's webinar, but it helps to kind of visualize things. And so we kind of simplified it further and underlaid these colors here. Again, the purple big blob is the power plant. We'll see that in a moment in a graphic. High voltage transmission continues in that color. Then we have the transformers as green elements, and then we have the sub-transmission and the distribution. So let's take a look at what this Edison grid really looks like from afar. Here is a picture of the network of power. This is not a geographical representation. It's a functional representation of an electric grid. Kind of resembles geography, but not exactly. I added some power plants to here, which I put on the high voltage transmission nodes. And then you have this transformer stepping down and getting to the sub-transmission. Now, while this looks complex already to start, we are only in the transmission part of things. Now let's kind of move out and see the grid edge. The grid edge is that distribution part of the power network. That's where you and I live. That's where your favorite gas station and your retailer are located. And so by zooming, before we go to apologize, let's just learn a term that's being used in the power industry, the hub and spoke. So, it's kind of conceptually obvious how this term came about, but you have this radiating network of transmission lines and then distribution lines outward. So that's where the term came from. And I think it's very, very well chosen. So back to the grid edge, we are now going to zoom in on that edge here. And we'll be visiting the distribution side of things. So we just added a few more transformers, and then we added these distribution lines and distribution connections to the homes. And let's populate this grid edge, and we'll see our familiar neighborhood. So we got our homes there. We got a Walgreens or other small commercial retailer. We have a gas station. So that's kind of what lives on the grid edge. And let's zoom in a little closer now and visit our residential and small commercial customers. And that's what we are concerned with today. And those are the type of customers that most recently have been exposed the most to power outages, because of course, the further you're away from the power plant, from the robust high voltage transmission, the more you're exposed to service interruptions and the like. So what do we have here in terms of power? So you're a long way away from the power plant to start with. And just for a little educational purposes, about 50% of all the losses happen on the grid edge. I'm not saying 50% losses are from the power plant to the load. It's about 5 to 10%, depending on the type of distribution and transmission system. But half of that actually occur within your distribution network, down your street. Those transformers on the poles are the primary source of losses in the transmission system. All right, so here we are back, and we're taking a look here at our loads. We have the residential customers. They have about 24 to 48 kilowatt of supply. That's measured at 240 volt, which you're not familiar with, but what indeed is the primary electric potential coming to your house. It's measured in Ampere, so 100 to 200 Ampere corresponds, if you multiply by 240, to those 24 to 48 kilowatt. And often you hear in utility speak or electrician talks, you have 100 or 200 amp supply. That's what this means. You would have between 24 and 48 kilowatt of peak power to your home. For the small commercial that are just up your street, the situation is similar, but slightly different. They have higher loads. We limited it here to 50 to 200 kilowatt because that's the kind of customer that YouSolar still kind of serves, and we call them small commercial. They typically receive their electricity not in single phase, but in three phase and a higher electric potential at 480 volt. What that means, not relevant, but for that reason, because they have three lines that share the current and they have a high electric potential, the current to them measured in amps is commensurate with what you receive in your home, but very different amounts of power. So, basically, double, triple, 4 times of what you receive. So who has 100 amps? That's your older homes that were built at the beginning of the electrification. Sometimes can even be less. This cottage style home here probably may only have 50 Ampere, only 12 kilowatt of supply. But as every home got bigger, the McMansions came to town and subdivisions started to grow. Demands increased, and homes typically today, the standard hookup is around 200 Ampere or 48 kilowatt. So the American dream has been built on 100 to 200 Ampere residential supply. The point here is that most of these lines, all these connections were all done at the same time. If you look at this neighborhood here, this beautiful ranch neighborhood, everyone has kind of a ranch house, and probably all of those customers received the same power supply from the utility. Presumably, these are all 100 Ampere connections here. So it's a uniform layout. You start with one type of power supply to entire division, and that's how utilities implemented the power supply to your home. However, changes are on the way, and this is going to cause some challenges for utilities and to the homeowners. So before we move on, just want to get something else out there and familiar with to you, the difference between peak load and the average load. So peak is the maximum sustained load here. That's how we think about it, that you can have in a home when an air conditioner runs and someone runs a dryer and lights are on. That's something that you measure in your bill. It shows up maybe in a 15-minute or 1 hour load, data, as compared to the average load. That's all your electricity consumption over the year divided by all hours in the year. And that ratio is about 1 to 10. And it's very typical for all the homes we have looked at, our own homes that we run with the PowerBloc and other data. And it's also, if you just look at Wikipedia and you look at electric power distribution, that's what you'll find. So there's a big difference between peak and average load. So one more time, looking at that, the more recent home, that would have this 200 ampere supply, about 48 kilowatt. It sometimes reaches above the 24, which we typically see as the sustained maximum peak demand in these homes. But it can increase above 24 kilowatt in these kind of hookups. But it rarely exceeds 48 kilowatt because hardly anyone has ever blown what we call the main breaker. So utilities have done well in the past to match the demands of these homes with their supply. Again, the average power is about 1/10 of that sustained peak and about 2.5 kilowatt. You can remember that figure in the back of your head, 1 to 5, 1 to 2, 1.5 to 2.5, something of that order is the average power in a home. But something is happening now, and what's coming to the market is the all-electric home. Here's a picture of an all-electric home, and these homes have 3 big loads that until recently didn't exist or were served by your natural gas supply or oil. You have EV charging. Here's shown as a level 2 charger. Depending on the charger you purchase, most people buy what's called a 30 or 40 amp charger. But it can be higher power, so you can get 7 to 15 kilowatts. Most people currently have 1 charger, but I can assure you, as people have 2 vehicles, they don't want to get up in the middle of the night and replug the vehicle. There'll be 2 chargers, and they'll be charging at the same time. So I would not be surprised if soon we'll see chargers hitting the electric load with some, 20 to 30 kilowatt at the times of the lowest rates when these cars charge. So that's something that runs for a couple hours, often 20 to 30, maybe even 40, 50 kilowatt hours. That's a lot of energy flowing to these cars. We have induction stoves. About half the country cooks on gas, but the other half is now moving over to induction stoves. They can be very massive. Now, typically, you don't have all the burners and the oven. But again, we're talking about the peak demand here. We're talking about Thanksgiving, when all burners are on and the turkey's in the oven. You can see those kind of loads. And the new really to the US, mainly to the colder parts of the United States, and because of the abundance of natural gas and the low cost of natural gas in this country, they're more prevalent already in the southeast, but heat pumps are coming as a main source of heating to the home, basically replacing the gas as gas boilers. And also hot water. So hot water, again, is a very large load in the house because of water's high heat capacity. So what's driving the electrification of the home? Certainly the electric vehicle, but also climate concerns. We hear this from our customers. They understand that natural gas is not the clean coal. It's by itself a very potent clean greenhouse gas when it escapes in the atmosphere from the drill sites and then doing transportation distribution. There are also concerns more recently voiced by the EPA about pollutants in the home from cooking with gas. But mostly people do not want the gas range anymore because of environmental climate concerns. But then it's obviously obvious understanding that they look at their home and say, like, wait a minute, we're not home during the day, or there's a lot of energy, electricity, we can use it at a later time. Why do we have a gas boiler when we have all this electricity in the house? So, and this lastly, safety. As you know, natural gas can be a danger, a safety danger in homes. Natural gas explosions are not unheard of. So all of this together, simplicity, climate, safety, health, all are driving the all-electric home. So at this point, we'd like to have a little question out to you folks. What do you think is going to be the impact on the overall energy consumption in residences with the advent of the electric home? Do you think it will actually slightly decrease because the electric appliances are more efficient in the way they use the energy? Will it about double, where heating and the electric vehicles are the biggest driver of energy consumption? Or is it actually going to be a quadrupling of demand, partly driven by climate change? So we're going to have a little pop quiz come up, and we appreciate if you would log your answers, and we'll see where you guys stand with your thoughts. So the quiz is up now. Thanks for clicking on the answers. Oh, wow, we got a nice participation here. And I'll give it a few more seconds here. Answers are still coming in. Okay, great. So what we have as a result is that 60% of all participants in the webinar believe it's going to quadruple. About 28% see it doubling, and about 11% expect it to remain the same. So we asked a leading consulting firm here what their expectations are. This is Wood Mackenzie, and Wood Mackenzie expects that energy demand will double in a residential home, not quite quadruple. Although, fair enough, we know that parts of the country have seen heat waves and cold snaps, and so that might drive both air conditioning and heating. But still, a doubling of energy consumption in residences is stunning. And so this is something utilities will be facing for the hookup to the home. Unfortunately, as we learned earlier, it's not just the energy flow to the homes that matters, also peak demand is all these appliances running at the same time. So what we are expecting, and we'll tell you a moment already seeing, is that these homes may need to upgrade from a 100, 200 ampere supply to 400 and 600 ampere. And if you look at the numbers, that's 150 to 100 to 150 kilowatt, you're looking at almost small commercial types of demands in the home. So electricity demand will go up 2x in the all-electric home. And here's a fact: utilities have no upgrade master plan. These homes will not uniformly, like the original American dream, upgrade the homes at the same time. There'll be one in the street that asked for an upgrade, that just bought the house, this beautiful ranch we saw earlier, is popping the roof, putting a second story on, getting the double EV charger, adding a hot tub to the house, all electric, of course, the induction stove, and God forbid, they actually have 2 dishwashers and 2 roasters for the turkey. And before you know it, they're going to come to utility, and the architect and their electrician does the calculation, says you need 600 ampere for your home. And we do have customers with all electric homes that are currently requiring 600 ampere or 150 kilowatt of utility service, and finding it, as we see in a moment, very difficult to get, if at all. So here's what happens. You go to utility. This is a chart from PG&E's website. This is for underground service, which you would assume people do not want overhead lines if they're already building this amazing new home. And you look at a very high cost and a huge backlog. This is just coming one at a time. It's a significant design engineering challenges utilities have to deal with. And so you're looking at costs, that can exceed $87,000. And certainly the homes that are happening right now, which are on the right-hand side in the higher end scale, they are seeing these kind of builds from PG&E and certainly other utilities as well. But before we go to the decentralization of the power grid, which will show you plays hand in hand with the electrification, I just want to note that other challenges to the central power system that are driving as well the next part of our webinar, which is the decentralized power. And one of them is obviously severe weather. We right now have this split country. We have parts of the country unusually warm, and we have other parts of the country that are about to go into the deep freeze. It was like -4 degrees this morning in the Denver area, while other parts of the country, famously New York City, are all balmy. Then you have the wildfires that come with it, service interruptions to prevent wildfires from even happening, direct service interruptions due to wildfire activity. So that all drives the desire to reduce the distance between where energy is created and where it is delivered. Large-scale renewables. Now we're further in our chart of the all-electric grid, of the electric grid. These renewables will change in terms of when they're available. I mean, obviously the sun doesn't shine at night. Wind also only blows at certain times of the day more prevalently. So you'll find that the kind of supply reliability from the central power plant that we've gotten used to, the electric grid operators have gotten used to, is waning. In California last year, we averted brownouts because of energy management. But this transition to renewables, especially as it doesn't play out consistently and well managed, may result in supply constraints on the upstream side of the power system, all again driving the idea on the grid edge that, well, I may want to take care of some of the energy and the power myself. So what to do? And the answer, in our view, is decentralized power. Now, before we go there, let's take a look at the central power system and just remind ourselves where all the loads are. And we are living on the edge of this grid. That's where the residential and commercial loads are located. And that's where we want to bring more of the generation, more of the storage. And then importantly, as we'll learn here in the webinar, we want to take power there. And that's something that's been missing to date in the entire discussion. All right, so here's a decentralized home again. This home we showed earlier. It also has a high power solar battery system. And all of it starts with the rooftop solar. We're going to generate energy where we are. We're not going to cover wild lands. It's on the roof. It's already black. So we're not even changing the albedo effect. The local heat island doesn't change. This is all climate neutral and environmental as much as it can get. We're going to add batteries to it. And we know lithium iron phosphate batteries are the staple of stationary power. Use very little to no rare earth materials. It's increasingly the battery of choice. And then we're going to add to that, as we'll make clear here and distinguish ourselves a bit, high power inverter. And we'll show in a moment why it's important to really kind of match up with the loads of the home. So what we have here is energy storage and power. So we have the solar panels providing the energy to the batteries, and then we have the battery power delivering that power to the inverter. There's usually a lot of power in the batteries, so there's hardly a constraint on the DC side. But on the inverter side, we're going to learn something here momentarily. If we look at the various solar battery systems out there in the market, and look at their specification, we're reading off 7 kilowatt, 5 kilowatt, 3.5 kilowatt, 9 kilowatt. Well, okay, but let's take a look at what we saw earlier. Even now, the home needs, let alone when it goes all electric, well, we're looking more something like 24 kilowatt or maybe even more. So with that, what we're discovering that in all of the current technology out there, if we want to move to true decentralized power, the inverter currently is a pinch point. And this is actually a very, very important moment of technology transition. We are on the cutting edge of getting the first single phase high power inverters in the market, which I'll show in a moment. But this is currently certainly something that is not obvious and readily available. This is something that we need to work on as an industry, and YouSolar is leading that by bringing and having brought the first high power single phase inverters into the market to kind of deliver the kind of power that the home actually needs. So that is the critical step, moving from the solar energy battery to a solar power battery with a high power inverter. So going back to our little neighborhood, this gentleman down the street, a little further away, owned and family, I should say, a lady as well, upgraded the home, included a solar battery power system to the all-electric life, and now the system, let's call it PowerBloc, is now delivering 600 ampere to the house, and the original connection remains at 200 amps. But as they start using it, they discover, well, we rarely use the 100 ampere, 200 ampere. It's much less than that. So we see a big reduction in the peak load, and utilities will certainly need this because the other family in the neighborhood did not upgrade the house to a PowerBloc, to independent power system. So they are still on there, and those extra amps will be very well received down the street. That is not hypothetical, is an example here. This is one of our PowerBlocs with a customer. It's a 22 kilowatt PowerBloc, but it only has a 6 kilowatt utility connection. So this home never can draw more than 6 kilowatt from utility, but delivers 32 kilowatt to the home. It kind of is an example of the kind of vision that we have here with our systems. So what it means, the PowerBloc will provide energy management. It will have no demand charges, if there were any. That's more for commercial customers. There will be demand response with no impact on customers. Again, if customers signs up for that, they don't have to drop their AC. They can just find another way to simply disconnect from the grid at all. We can buy, the PowerBloc can buy the cheapest energy available on the grid, because with the large energy storage, you can buffer that energy. And during the summer, these systems will entirely disappear from the grid at all. So let's go back one more time and see how this all now ties into the service upgrades, which are high cost and have a long backlog. And let's compare the two choices that customers we're working with right now, their builders and architects, electricians are dealing with, and the decisions they make. So I can get a service upgrade. I'll pay $10,000 or $100,000 to utility. I have a huge backlog. I'm on timeline. I'm just trying to build this home. Architect says within 18, 24 months we can move in. I haven't heard back from the utility at all. Even if everything works out, I'm still in utility power. I'm still exposed to the outages we earlier described related to climate and also these, supply problems due to the large penetration of renewables. I have no control over future electricity prices. I'm continue to be a ratepayer. I have to change my behavior in response to time of use pricing or demand charges. And I have really no or little choice over the energy mix I'm receiving. Maybe there's some clean energy programs I can buy into. But other than that, I paid up to $100,000, or some customers even more, but I'm still a utility customer. In contrast, if you get a high power solar battery system, some of that money you would have paid for a utility upgrade now pays for the system. You can get the PowerBloc and make that change when you want. In particular, with the PowerBloc, no utilities approval is required. I'll show you later a map. And these customers in the middle of Calistoga have not required utility approval, but they can go up from 200 to 400 or 600 amp. You're protected from outages. You have fixed energy costs from the solar roof. And the PowerBloc's energy management system will handle all of your time of use concerns and peak power, and you just live as you like, as it fits your schedule. And you will have clean solar energy instead of worrying about where your electricity comes from. So the PowerBloc is, as a result, a very compelling alternative to these service upgrades. So it's not just reliability concerns alone or wanting to go green that drive our customers. It's also just a financial decision and kind of a convenience and planning decision that drives them to choose a PowerBloc. So we believe that tomorrow's network will be that of a mesh. We will have all these little red dots here that represent the various independent power systems. They will help with the purple areas now being power plants and more variable because many of them will be renewable. It will relieve transmission congestions that will already occur regardless because of the electrification of everything. Electric vehicles are not just plugged in at a home. They're also plugged in apartment buildings in a city where you cannot have these type of independent power systems. So utilities and regulators will be delighted to know that there will be load coming off the grid, not just in terms of energy, but also in terms of peak power. So where are the customers? The New York Times said an article about a year ago that they're right at our doorstep in California, that frustrated with utilities, and we won't name a name here. These customers are leaving the grid. We can confirm that that's indeed happening. Our customers typically don't leave the grid, but they want to have their own independent power and take what they have and supplement, and definitely like the idea that specifically with the PowerBloc, they do not have to talk to utility about interconnecting the PowerBloc with utility systems, as this is a one-way street. We only sourcing some energy, as you saw earlier, some 6 kilowatt, but would never put energy back onto the grid. So they're off-grid in the sense that they form their own grid and source some energy from utilities, but often in the summer disconnect basically entirely. Those connections just turn off. Where are we right now with projects in California? We have 8 operating systems. 2 of them are off-grid. The other ones are off-grid in the sense that they're grid connected, but not grid tied. And they are in and around Calistoga, most of them, also in Vallejo. And we currently have signed 2 contracts. The third one is pending down in Big Sur for very large homes of the 400 to 600 ampere type that I described. And we expect to have another 30 projects on this map by the end of the year. So definitely we have a good market, a strong market here right in front of our doorstep. New York Times said millions of people could eventually go off the grid as cost drops. We concur, but we believe it's going to be slightly different. We don't think people will disconnect. We believe people will look at the grid as a source of energy at times, but want to provide their primary power and their resiliency independently. So we quite don't agree with that, but we do agree that these independent power systems are going to be very, very popular, and we can assure you with the interest we have in our product, that is definitely the case. So a little bit about the PowerBloc towards the end of the seminar, because it's really what we built to address this need and drive this transformation. We call it a nano-grid because it's a system that can interconnect different sources and kind of acts like a little power plant, just like a little utility in terms of how it manages energy and everything. One of the key features of the PowerBloc, it's an all direct current architecture that is fully parallel. So we can build up systems in size from the same building blocks, from these kind of modest systems you see right now here, to a system in a moment that contains 7-foot tall cabinets. The extension of the parallel network also is on the roof. We have a DC-DC microconverter on each panel, not to be confused with a optimizer. This is more an equivalent to a microinverter, such as those by Enphase, only that we are stepping up directly to the high electric potential of that bus, in which everything operates at direct current potential. It makes a lot of sense. If you have batteries in your system, why would you create AC power on the roof within a microinverter to rectify and put a battery and then have another inverter to get it out of the battery again? So we operate entirely on direct current, has a lot of structural and design advantages, and that's the PowerBloc. And of course, it gives us the enormous scalability. We can have the same system build a 5 kilowatt solar array with 20 kilowatt hours of storage. You can have a 50 kilowatt solar array with 500 kilowatt hour storage. It's the same product. It just scales up. We are multi-source. We can bring in everything, but typically it is solar and the grid and the generator. But most recently, we also added a vehicle to home. And we have sold and the first projects with vehicle to home recently. So we, as a grid farming system, again, if you provide your own power, you are both on and off grid at the same time. So it really doesn't make a difference. We source energy from the grid like a type of solar panel. By the design, we don't net meter. That's also possible. But most of our customers do not want that, because the moment you do that, you have to engage with the utility. And that can, again, slow you down. Exactly what you were hoping to avoid by doing your own power upgrade using a PowerBloc. The PowerBloc by design is also plug and play. Behind me, if you can see on the video, is the kind of new design that you see here in the picture. It's a stackable system in which the order of modules doesn't even matter. It's fully plug and play. All the system components register themselves on the system. This is not your normal stackable system where you have to wire up anything. This is entirely plug and play, and we think it's going to be revolutionary. And we hope to show it this fall at the trade show in Las Vegas as a product. But it's the same PowerBloc inside that you already have seen before and that our customers currently enjoy. The PowerBloc is fully automated. We have our own satellite-based solar production forecast that we send to each PowerBloc on an hourly basis. It then uses load forecasting to decide the reserve level of the batteries, how much to keep, how much solar is coming tomorrow versus load. So we do the maximum solar self-consumption in the home, and also maximize any protection of the home against outages. So it's a fully dynamic and intelligent system. You can also include generators for those who want extra reliability, or the car. And when that car gets turned off and charged, a generator, all that's fully handled by the PowerBloc. So replicates, hopefully, the perfect utility that you hoped you had. In conclusion, we see the all-electric life and decentralized power kind of merging and connecting that two different sides of it. One tries to take the power, the other one tries to add the power. So like the yin and yang conflict, but fortunately they kind of work together, and we see that both of them are going to come in a very strong way. And we believe and anticipate and see that these high power solar batteries will disrupt the trillion-dollar utility industry in a way that has not been possible by just grid-tied solar, which always has remained and kept utility in charge. It hasn't really structurally supported the electric grid, as you may know from many regulatory discussions and the famous term of the duck curve, which refers to the shape of a bird with a long neck that explains or suggests the high increase in demand the moment the sun goes down at the end of the day, and utilities are left to save the lights by powering up their power plants. All of the things are being addressed by high power solar battery power systems. Leadership, again, I'm Arnold Leitner. I'm the CEO and founder. Mike Allman, the former CEO of Ampere Generation, who built the first utility-owned solar power plant in Desert Southwest a long time ago now, but definitely led the way and built hundreds of megawatts of solar, is one of our directors and main investor. Rupert Meyer, a former tech entrepreneur, is our chief financial officer. And Galen is our chief operating officer. He's built multiple utility scale megawatt sized plants and brings a lot of construction experience to the company. With this, I'd like to open it up to your questions. I hope you enjoyed the webinar and learned something. We always try to make sure that people enjoy and take something away. So with this, I'd like to just one more time remind you that we have a Start Engine campaign, a crowdfunding campaign, our second one that again broke the $1 million mark. It is on Start Engine. So if you like what you saw and you want to invest in the future of power, which we believe we represent, please go to startengine.com/YouSolar. We'll redirect you immediately to our campaign page, and you're welcome to invest. Anyone can invest in these crowdfunding platforms. There are no accredited investor restrictions. With this, I welcome your questions. There's a chat box, I understand, where you can add your question, and I will receive those here from our moderator. So look forward to all questions you have. We'll probably give it about 10 minutes or so, or 50 minutes the most, so that we can keep it within the hour. Look forward to seeing what your thoughts are. Thank you so much for being in this webinar, and I look forward to your thoughts. All right, so I got the first question here. Electric companies do not want customers to leave the grid or lower their current use. They lose control. So how is this 200 Ampere upgrade going to work? And how do you get approval for these large batteries? That's an excellent question. So the point about these independent power systems is that utilities really have no control of it. Specifically, one project we're doing right now, which has 150 kilowatt connection just to the main house. There's a second house that has its own 100 kilowatt supply. The reason this moves forward is because the owner does not even want to engage with the utility. Since we're only taking power from the grid, no different than like an Apple iPhone charger. Anything takes energy through a rectifier. It doesn't require utility approval. Now, the consequences for utility are quite significant. Now, they will need, unlike these customers disappearing from the grid, however, these are their best customers. These are customers that are consuming 50,000 kilowatt hours a year at sometimes in California, these high 40 cents per kilowatt hour rates. So the very best customers are disappearing. They're not making money on these utility upgrades. The answer is it is something they can't prevent from happening. The other thought, of course, would be for them to enter this business and be the ones that providing these kind of systems to customers, and has many benefits to them, including that on customers at the end of the line, like we showed in our graphic, when they lose power from utility supply, they don't have to respond right away. Those systems will operate by themselves independently until power can be restored. So the answer is no, utilities currently are not in a position to stop this from happening. And on the other side, it also provides enormous opportunities for utilities. So looking forward to another question here. All right, so it comes back to the battery life. So batteries' lives is measured in cycles. Unfortunately, unlike in the automotive industry, there's no clean definition of what cycle means. It often refers to full charge and discharge of the battery from zero state of charge to 100% of state of charge, often at certain discharge rates, ... In actual operation in a day, a battery obviously cycles once, ideally. But the range of which we allow batteries to cycle is about a 20 to 80% state of charge, so about 60% of their range. As you noted earlier, although these batteries are able to deliver very high power, including these surge powers, the most common discharge rate is only 5% of the maximum power of the batteries. So they're treated very gently. Therefore, we expect these batteries to last about 10 to 15 years, thousands of cycles. We will probably have a webinar just on the question of high power inverters and batteries, and the interest of us and others in certain direct current appliances. that will all work very well with batteries, but we'll defer that another day. But right now, 10 to 15 years is kind of what you can expect from these batteries. Okay, let's see if there's another question here. So can these systems, the PowerBloc specifically, integrate microturbines, wind microturbines, microhydro? The answer is yes. Very often the output also from fuel cells. We have one customer that was on our map that will add a hydrogen fuel cell. Often their output potential is at about 50 volt, 48 volt. Our power electronics is exactly designed for that, so we can integrate those kind of systems and bring them on the high voltage bus. And that's what we tried to suggest earlier with that graphic of the multi-source PowerBloc. So the answer is yes. But I will say that for most people, solar is simply the best and most practical solution. All right. Good. The question is here, how can we get to exponential growth? There is a slight difference between a grid-tied system that just adds energy and a primary power system like the PowerBloc. I'll be honest with you, most people don't even notice if the solar array didn't work for a couple of days. But they definitely will know if the lights go out in the house. So the design requirements are a little bit more stringent and more detailed. But in general, the way we want to scale is by offering a standardized system, and we'll add to our website a design tool that allows our installers and partners to design systems entirely on their own. And one way to address some of these design issues is by delivering a very large amount of power at very competitive cost, so that any details of what load is on the house is irrelevant. Therefore, we do not offer any kind of systems in less than 100 Ampere increments. So you buy 25 kilowatt at a time, and that reflects the utility system. So therefore, the planning becomes much, much simpler. So you just buy 25 kilowatt, 100 amp, and design your system. And of course, the stackable PowerBloc behind us will take all the hassle of wiring and understanding even the PowerBloc out of the way. You just have very simple inputs and outputs into the system. And that's really our goal, to really get from, handful systems to a couple dozen systems this year to 1,000 millions of systems in the United States and worldwide. So let's see, we have another question here. Okay, so the question is island power, anyone in a remote environment that is de facto off-grid. So the PowerBloc doesn't make a distinction between whether it's grid, on the grid, or off-grid. It has a grid-forming inverter. It defines the network to the home. It can scale up, as I noted, and just want to repeat, up to 200 kilowatt is what we do. Our customers currently are all in the 100 to 150 kilowatt range. And then it sources energy from the grid, and if the grid is available, and also, and if and only at any quality of the grid power. So these kind of what we call a rectifier, the extend module that brings in grid energy, can take electricity at very, very bad conditions. So that's for emerging markets. For example, this question here came from someone in Bali, where coincidentally we have installed a grid-tied solar array as a donation we made to the Green School Bali. And at the time, we had to contact Fronius, the grid-tied inverter we used for this project, and get additional code and a secret menu to override the voltage band that was standard in the Fronius, which just couldn't handle the grid in Bali. And I'll point out that Bali probably has, of all emerging markets, the best grid, period. So the kind of approach we're taking through this rectifier really lends itself to markets such as this question that came from this gentleman in Bali. And so, yes, that's really where we want to move as a company also, is these markets with poor grids. So the question is, are the batteries the highest cost element in the system? Yes and no. We operate differently from most solar battery companies in that the current design of the PowerBloc uses the battery like a tire on a wheel. It is a wear and tear item, it lasts 10, 15 years, but it can be easily replaced. And replacement time for an individual battery on a PowerBloc, I would say, is about 10 minutes at the most, 5 kilowatt hours. We replace it and put a new unit in. We have done it. already with one of our customers. One of our battery packs just failed. The battery management system died. Took about, within a day, this was replaced, and took about 10-15 minutes to swap out the batteries. Because we use standard now 50, but in the next system 100-volt batteries, and that are made in very large volumes and have no power electronics inside, our cost of batteries is relatively low. They are a major part of the system, but they're not the biggest part. I think, between the solar array, the installation costs, and all the other power electronics, I would say they account for a third, depending on the size of your system. So there's another question you have here. Okay, so the question was, companies like Tesla offer, I believe it's the IQ or something similar, N-phase inverter, microinverter with its product. Yes, the PowerBloc offers the entire spectrum. The solar panel power electronics called the step microconverter as part of the PowerBloc, and essential to operate it, because it really extends the parallel architecture to every single solar panel. And we provide everything. The only thing we don't do, and this is true, I think, also for Tesla, an example, or Enphase, we don't do the solar panels and the racking. We work with contractors, solar installers. We provide the PowerBloc step microconverter to them, and it's a very simple task of integrating them into the solar array. So that's already a model that's common, and that's the model we are following. But it's a one-stop shop with the PowerBloc and YouSolar. Let's see, we have another question coming in. So question is, how difficult will be the PowerBloc to install? It is currently, with the cabinets that we're developing now, that we're shipping now, what I meant is the stackable unit. With the current cabinets, it is pretty straightforward. We currently need to do all the filling of the cabinets, which ship empty. But going forward, we'll have the stackable unit that you see behind us. Anyone can stack this together. There's actually a video on our YouTube channel, which I recommend to you to see, where I, within 3 or 4 minutes, stack up the system behind myself. It is actually that easy. Beyond that point is the interconnection of the solar array, of a generator, or any other sources, such as a fuel cell, and the connection to the home. But if you have solar, utility, and home loads, and that's your basic setup, it should be very, very easy to do. And that's really where we're moving towards. So let's see if there's another question coming in. We said we're going to keep it to another 10 minutes. So we're coming to the end here. And yes, so I think we may have come to the end, but there was a few more questions. One more coming here. So question is, if I already have solar, how can I use the PowerBloc? If you have a legacy system that uses Enphase or Solar Edge, you would not be able to use its panel level power electronics, especially if they integrated into the panel. That would not work. But recall that many of the first wave of solar in the United States was using string inverters. Those folks have mostly paid off the systems, or are done with that, looking to retrofit. For them, it's not a problem at all. If you have a string array, straightforward. But the primary market we're looking at is really the emergence of solar as a primary power source in the world. And we're far, far away from limits. And so, yes, if you're retrofitting Enphase or Solar Edge systems or other microinverter systems, if the microinverter or optimizer can be detached or is not functioning, straightforward, no problem at all. If they integrate into the panel, unfortunately, would not be able to use the panels and or the inverter. Okay, let's see if there's another question here. I always have to look over to my little phone here. Okay, so the question was now from an investor point of view, what is our expected time to an exit when investor can monetize the investment? So we have developed and sold to our first customers. This year will be the second round of sales installation with a mature product. And then we're going to move into the high volume product of the stackable PowerBloc probably in 2024 and probably more 2025. We believe that with that time, we have a customer base, we have some kind of a data, statistics, and market experience that is relevant to large investors, including those that are interested in acquiring the company. So I would say that for an exit, we're still looking at 3 to 4 years for YouSolar. So if you're an investor, please make sure you have a timeline, a time horizon for your investment that is commensurate with that time frame. Okay, I'll take one more last question if it's coming in. Okay, so that's a very nice question. And the webinar, is a recording of the webinar available after this? Yes, it will be available, and we'll be sending it to everyone who has registered to the webinar or just signed up here using the link. So with this, thank you so much for being on this webinar. I'll forward the slide to show my contact information. You can reach me at arnold.leitner@yousolar.com or visit our website. We look forward to hearing from you. We are very excited for what's coming this year. We just attended Intersolar in Long Beach, and we know and see that there's enormous activity. It seems like the storage and solar, the storage market is really driving the solar market right now, which I'm very grateful to see, because that's really where solar needs to go to make a meaningful impact and a big contribution to our energy supply system. So thank you so much again for attending this webinar on the all-electric life and the decentralization of our power systems. With this, goodbye from California. This is Arnold Leitner with YouSolar. Thank you and have a great day.